Salam sejahtera, tajahau, everyday ingredient and welcome. So before I begin, I would like to explain on energy. So what is energy? Energy is a key ingredient to any economic activity. For more than a century, we have been using a fossil fuel as our mainstream of energy source. Burning of fossil fuel has generated most of our energy required to propel our cars, to power our business, and to keep our lights on in our home. Even today, oil, coal, and gas provide about 80% of our energy needs. However, there is a bad side of using a fossil fuel as it emits a harmful air pollutants long before they have been burned. So from this is as indication for us to switch from a dirty energy to green energy. So green energy is a renewable energy, and renewable energy is often referred as a clean energy come from a natural source or process that constantly replenish. So what type of the question here today is what type of natural source and the green energy that we can harvest in Malaysia? So here I am today to address the issue which related to my final year project title. So my final year project title is Bioenergy by Anaerobic Digestion from Palm Oil Mill Effluent, presented by me, Arone Gehinan, 65482. As increasing demand of energy due to the rapid propulsion and industrial growth has led to the development of POME, palm oil mill effluent, as a source of a sustainable bioenergy. So bioenergy is energy resource that originates from a biogenic material and is a type of a biogas we can use to fuel replacement, cooking purposes, and by energy generation, and etc. So it's been produced by the biological breakdown of organic matter in the absence of oxygen, which is often called as anaerobic digestion. So for my content of presentation, I will begin with the introduction. We will cover the background of research, problem statement, research objectives, scope of work, and novelty. And then I will go for a literature review, which will demonstrate the POME characteristic, anaerobic digestion, POME biogas composition, and research gap. And lastly, I will go for the methodology, which will wrap all the overview of research methodology and research methodology in achieving objective 1, objective 2, and objective 3. And last, we'll left with a Q&A section with the examiners. So here is my project planning for semester 1 and semester 2 as shown in the screen. So we'll start with the introduction. Malaysia presently produces 39% of the world palm oil, which is around 17.17 million tons, accounting around 44% of the worldwide export market share. And Sarawak itself, palm oil sector itself is around 8.0 billion ringgit, which is contribute to the significantly to the state of economy, particularly in terms of job creation and economic development, as stated by Shahidul et al. In 2018. So on the this is concerned as a Malaysia worry about the proper deposit of effluent from palm oil mill, as Malaysia itself is the world biggest producer of POME. So POME is a most harmful kind of pollution created by the palm oil sector due to its high organic content. On the other hand, POME is a non-toxic byproduct that contributes to the environmental ecological discomfort because to its high capacity for the oxygen content. As we know, POME has been recognized as a possible source of renewable energy via anaerobic digestion, which benefit the palm oil sector greatly. So there has been a lot of interest and finding on sustainable and cost-effective technique in generating renewable energy from biomass. And one of it is anaerobic digestion, is most often used technique in treating POME. So for the problem statement, fossil fuel emit pollutant particles which contribute to the climate action, and many research and innovation technologies have been researched and introduced in order to reduce the carbon emission and the greenhouse gases. So the concern here brought us to our first research question, which is how to generate the biogas as a bioenergy from POME by anaerobic degradation process. From the study will brought us to an outcome, which is the biogas generation in contributing Standard Development Goal 7, which is clean energies, as stated by United Nations. And next, POME generate a large amount of highly polluted effluent, which is a thick brownish slurry wedge containing water dissolved palm organic fragments. As a Department of Environment and Malaysian Palm Oil Board, MPOB, it is essential to treat POME before a final discharge. So here brought us to our second research question, which is what is the characteristic and the properties of POME in maximizing the biogas production. Here we come to extend our study into our third research question, which is what is the efficiency of solid separation by gravity settling system of POME in anaerobic digestion. And lastly, to address the reduction of carbon emission in replacing fossil fuel, the study is to convey what is the bioenergy potential of POME by anaerobic reactor. So the research objective of the study, the broad objective of study is to evaluate the biogas production from POME by anaerobic digestion in maintaining the secure and sustainable renewable energy supply chain as well as environmental sustainability. So the broad objective research is divided into three specific objectives, which is characterization of properties of POME, evaluating a suspended solid separation in gravity settling system, and then lastly, we'll evaluate the bioenergy potential of POME by anaerobic reactor. So the scope of work in order to achieving the objective is to perform the evaluation of biogas from POME using a laboratory scale anaerobic reactor, which is a 2 stages anaerobic reactor. And then next, in order to achieving a specific objective, is to characterize the properties of POME by using a water analysis, which is using a HACH DR900 provided by the chemical department of Faculty Engineering UNIMAS. And then next is to evaluate the total solid suspended separation TSS efficiency by using a gravity settling system from 2 anaerobic reactor. And lastly is to collect the biogas from 2 stages of anaerobic reactor using a combi-mass portable gas analyzer. So the novelty of research is to design and to study the bioenergy from POME. However, on evaluating the efficiency of TSS separation by a gravity settling system in a batch reactor is not well published in the journal. And then the bioenergy is from anaerobic reactor is not a new thing and not a hot potato, but lack of published journal. And this aspect, this research is novel. And then we go for the literature review. So here we have a POME characteristic table. So POME is an accession source which dumped into a nearby river or lakes without treated. Again, POME is referred as a final product obtained from the palm oil. From the table, we can see the general characteristic of POME is highly in concentration of chemical oxygen demand (COD) and biochemical oxygen demand (BOD). So at the range of temperature at 80 and 90, which is at a thermophilic state, and the pH at 3.4 until 5.2, a poor removal efficiency will lead a major environmental pollutant in Malaysia. So the characteristic of POME, from the characteristic of POME, we can understand how POME behave when discharged directly to the water. The suspended solid and the nutrient content of POME could be able to support the growth of algae, which was the agent for the biomass production for the bioenergy potential. And then we have anaerobic digestion. So anaerobic digestion is a biological process that is highly reliant on the existing of a favorable environment and the condition to survive the metabolism. Anaerobic digestion is a complex by process which is a bacteria from a different functional group will collaborate and degrade the various organic compounds in order to produce a methane and carbon dioxide, CH4 and CO2. Numerous factors including the digester's design, feedstock, feedstock, temperature, and other parameters may have affected the organization of the microbial pollution. So from the figure on the screen, here is the processes happen in the anaerobic digestion. So it started with the hydrolysis and then go to the acidogenesis, acetogenesis, and metadogenesis. So a complex organic metal such as carbohydrate, protein, and fat from POME will undergo hydrolysis to form a complex organic molecule to solute. And then we go to the acidogenesis, which is the component, the complex metal will we go to the small organic molecules to fatty acid. And then after that, we go to acetogenesis with the conversion of the acetic acid from the acetogenesis, conversion to acetic acid and CO2. And lastly, the most essential part in anaerobic digestion is a metagenesis, which is the final conversion is a biogas CH4. And then here we have our POME as a biogas composition. So from the table of POME biogas composition, as we can see here, methane is the highest concentration of composition, which is around 50 until 75 volume%. And then we have a carbon dioxide, which is CO2, around 25 until 45% of volume%, which is the final product of the anaerobic digestion. So from the literature review, the variable that affect the composition of biogas is such as hydraulic retention time, HRT, SRT is a unit measurement of time, or how long does the POME will spend in the reactor. And then we have a solid retention time, SRT, which is a parameter that has substantial effects on the methane generation. And we also have organic loading rate, which is a critical efficiency in attaining operational efficiency. So beside from that, there's other factors and variables that affect biogas production, such as pH, carbon to nitrogen, and temperature. So those parameter is actually provide a favorable composition for the microbial to digest the product into CH4 and carbon dioxide as a final product of the anaerobic digester. And then for the resource gap, so the effect variable, as I mentioned, such as organic loading rate, carbon to nitrogen, and SRT on the bioenergy production is essential, as it provides the optimum data for the biogas production. So two-stage fermentation on anaerobic reactor will provide optimum data on bioenergy potential, despite the two stages itself is a cost-effective and sustainable. So lastly, for the gravity settling system, which was not well published, and the study is to address the research question. So we'll be continue with the methodology. So for the methodology, here is the overview research methodology for the whole project. So the methodology we started with problem identification and literature review, and we'll continue with the overview of experiment design. So from the problem identification, at here we can identify the dependent variable for the methane production and the carbon dioxide production, and independent variable such as hydraulic retention time, organic loading rate, and carbon to nitrogen ratio. So from the variable itself, we can evaluate the effect on the variable, and the data will be computed in OBA, which is online biogas apps. So what is type of data that we're going to compute in the OBA? The type of data that we're going to compute in the OBA is CH4 and CO2, which we collected from the anaerobic digester by using a portable gas analyzer. So does the biogas energy potential was the output of anaerobic reactor? If no, we will started from the effect of variable, and then if yes, we will continue to record the data and report rating. So research methodology in achieving objective one. So objective one is to characterize the properties of POME. So to characterize the properties of POME, started with problem identification and literature review. And then we will collect the raw POME from BAPOM, which is bulk palm oil mill, and we test for the psychochemical properties of POME by using our water analysis and HACS DR900, which provided at the Department of Chemical Engineering. And this the physicochemical properties of data was collected. If yes, we can continue with data recording. If no, we will start again with the overview of experiment design. So here is research methodology in achieving objective 2. So objective 2 is to evaluate the total suspended solid separation efficiency by gravity settling system. We started with problem identification and then overview of experiment design. So in order to conduct the TSS separation efficiency, we collect the source from an anaerobic reactor, and then we perform the water analysis and compare the data from the properties from objective 1 to test for the efficiency of separation. And this the efficiency of TSS separation gravity settling system for 2 anaerobic reactor was collected. If no, we will start again with the overview of experiment design. If yes, we will continue to recording data and rating the report. And lastly, research methodology in achieving objective 3, which is to evaluate the biogas potential in anaerobic digester. So in order to evaluate, we are testing the variable, independent and dependent variable, and then the biogas that produced in a anaerobic reactor will be collected by using the water displacement method, and then from the water displacement method, we also will perform evaluation on CH4 and CO2 by using portable gas analyzer, and then we evaluate the variable on the experiment. So does the biogas energy potential was the output of anaerobic reactor? If no, we will start again with the overview of experiment design. If yes, we continue report data and report writing. So lastly, we go to the Q&A session. So for the Q&A session, I will let the examiner to ask the question. And to end my presentation, I wish all a good day to the examiner and have a blessing day. That's all from me. Thank you.